Hey y'all, long time no see. So today we're doing the 6.2-1 notes on trigonometric functions with the unit circle. So the first thing we're going to look at is right triangle trig. So taking it back to geometry. So I'm going to look at the triangle on the right side and label to this angle what each side is. And that is a theta. I'll draw it better. Theta. So theta just represents angle. So this side here is right next to the theta. So that is our adjacent side. So we're going to label it adjacent. This side here, across from the right angle, always across from the right angle is your hypotenuse. So this is our hypotenuse. And then across from theta, so the angle you're looking at, and then across from it is your opposite side. So this is opposite. Now this works only when theta is in this corner. If theta was over in the other corner, then this would look a little bit different. But here, we're looking at theta over in this corner, so that is our opposite, hypotenuse, and adjacent. So let's go back and look at what sine is. If we remember SOHCAHTOA, sine is this right here. So SOHCAHTOA, this is sine, this is opposite, and this is the hypotenuse. And it's always the first one over the second one. So sine is the opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. Tangent, this is tan, is op over adjacent. So now we have the cosecant, the secant, and the cotangent. So these are just, cosecant is just 1 over sine. And really, when we're using like opposite hypotenuse and stuff, you just flip it. You just flip what sine is. So sine is opposite over hypotenuse. So cosecant, which is 1 over sine, is really hypotenuse over opposite. Secant is 1 over cosine. So we're going to flip what cosine is. So hypotenuse over adjacent. Cotangent is 1 over tan, which equals adjacent over opposite. Okay, next we're looking at the special right triangles. So back to geometry again. So let's look at a 45, 45, 90 triangle. We have to go back and remember those rules that the hypotenuse is x, and then the sides are square root 2 over 2 times x. Square root 2 over 2 times x. And then these are just those rules. So going to our 30, 60, 90. The hypotenuse is x. And then to get to the short leg, we multiply it by 1/2. And then to get to your long leg, you multiply the hypotenuse by root 3 over 2x. Alright, so now we're going to go find the sine, cosine, tangent, cosecant of all the angles of these in the 45, 30, to 60. And we just built triangles, and we know our right triangle, SOHCAHTOA, so we can figure these out. So 30, we're looking at angle 30 first. So theta is here, which means the 1/2 x is the opposite. The root 3 over 2 over x is our adjacent now, and x is the hypotenuse. So sine is opposite over hypotenuse. So 1/2 x over x. So 1/2 x over x, which just equals 1/2 because the x cancel. Now let's look at cosine. Cosine is adjacent over hypotenuse. So root 3 over 2 x over x. So square root 3 over 2 times x over x. X's cancel again. So cosine of 30 equals root 3 over 2. All right, tangent is the opposite over the adjacent. So I'm going to do this one down here. So 1/2 x over root 3 over 2 times x. Again, those x's cancel. And then I have 1/2 over root 3 over 2. I'm going to multiply by the reciprocal. So I'm going to have 1/2 times 2 over square root 3. Those 2's cancel, so I get 1 over square root 3. But remember, can't have a radical in your denominator, so we're going to multiply the top and the bottom by square root 3. That will get us root 3 over 3. So tangent 30 is root 3 over 3. And then what is it again when you go from sine to cosecant? That's right, it's just 1 over sine. So if we have 1 over sine, which was 1/2, so 1 over 1/2, multiply by the reciprocal, 1 times 2 over 1, that equals 2. So our cosecant is 2. Secant then would be 1 over square root 3 over 2, which equals 1 times 2 over square root 3, which equals 2 over square root 3. Again, can't have that radical in the denominator, so I'm going to multiply the top and bottom by square root 3, and I'm going to get 2 root 3 over 3. So secant is 2 square root 3 over 3. Okay, cotangent. We'll just flip tangent. So we started with tangent of 1/2 over square root 3 over 2. So I'm going to change that to be square root 3 over 2 divided by 1/2. 1/2. So I'm going to take this, multiply by the reciprocal, times 2 over 1, and I'm going to get the square root of 3. So the cotangent is square root 3. All right, that's 30 degrees for what sine, cosine, tangent, cosecant, secant, cotangent of 30 is, and we just did that by hand instead of putting it in the calculator. So whenever you can't use a calculator and you're trying to figure those out, remember, go back to special triangles and use SOHCAHTOA. So let's go and fill out 45 and 60. You're going to apply those same rules, what we just did for 30, but I'll just give you what each thing is. So this is root 2 over 2, square root 2 over 2, 1, root 2, 1, and then 60 degrees is square root 3 over 2, 1/2, square root 3, 2 root 3 over 3, 2, and square root 3 over 3. All right. Next, we're going to look at the unit circle and a circle of the radius. So the radius on the unit circle is 1 unit. This is always for the unit circle. And if we are looking at this triangle that they gave us, and we're trying to find the sine of theta, so this is our theta here in that corner. The sine is opposite over hypotenuse. So that would be y over 1. And then if I just solve for y, I'm going to multiply both sides by 1. and I get y equals sine theta. All right, now let's look at cosine. Cosine theta would equal x over 1. Multiply both sides by 1 so I can solve for x. X equals cosine theta. All right, what about tangent? So tangent would equal y over x because it's opposite over adjacent. So y over x. And then above, we know that y equals sine theta, and we know that x equals cosine theta. So tan theta equals sine theta over cosine theta. This is going to help us when we build our unit circle. So let's take a look. All right. So what we are going to fill out is first the degrees. So this is 0, 30, 45, 60, 90. This is 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and then fully around is 360. All right, now we're going to do the radians. So 0 is just 0. 30 is pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. You know the song, we did a full 180. So now we can say we did a full pi. And then that's half of a circle. Just a little trick. And then next we have 7 pi over 6. And then 5 pi over 4. 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. 11 pi over 6. And then a full circle is 2 pi. All right. So next, let's look at what's positive and negative. So if we just think of this as a graph, in this first quadrant, the x's are positive and the y's are positive. So that means if the x's are positive, that's cosine. So cosine is positive. And the y's are positive, which is sine. So sine is positive. And tangent is sine divided by cosine. Two positives divided by each other are positive. So tangent. All right, the next one. Let's think again. Our y is still positive, so that's sine. Our x is now negative, which is cosine. And then a positive divided by a negative is negative. So tangent would be negative. All right. Now both x and y, so sine and cosine, are negative. And then two negatives, so a negative divided by a negative is a positive. And then for the last one, we have the x is positive, which is cosine. And y is negative, which is sine. And then a negative divided by a positive is a negative. So tangent is negative. Okay, and now we just label. So on our point, we have x comma y. So remember our unit circle, the radius is 1. So if we go out 1, but we didn't move any, okay? And then x comma y, so cosine comma sine. This is when we'll use that table from above. So cosine of 30 was root 3 over 2, and the sine was 1/2. 45 is root 2 over 2, root 2 over 2. 60 was 1/2, and then root 3 over 2. And then now we didn't move any, but we went up 1 because the radius was 1. Okay. 120 is the same as 60. So, because if we went this way, we go up 60 degrees. So that's its reference angle. So we have the same as 60. But 1 is going to be negative, or outside, because we went in the negative x direction. All right, so this is negative root 2 over 2, positive root 2 over 2, negative root 3 over 2, comma 1/2. Then we went negative 1 direction, and then 0. And then fill out the bottom half. We have, now both are negative. So negative root 3 over 2, negative 1/2. Negative root 2 over 2, negative root 2 over 2. Negative 1/2, negative root 3 over 2. Now we went 0 in the x direction, the negative 1 in the y. All right, now x is positive, y is negative. So 1/2, negative root 3 over 2. Root 2 over 2, negative root 2 over 2. Root 3 over 2, negative 1/2. So that is our completed unit circle, and that was a long video, but that is the end. So if you have any questions, please let me know.